All right. Correct me if I'm wrong, but I believe this is approximately where we left off. We probably start on the next slide. Would that be accurate?
We ended with the hormones of the adrenal system.
Okay.
That's the one that we're on today.
Okay. Very good. And some of you have that we started a table of categorizing these hormones. We will elaborate upon that a little bit later on today. Now, one of the aspects we've only just said, oh, I guess it says it up here anyway. Okay. Let's say we only verbally said this in class. A good rule of thumb is to remember when your body's trying to conserve water, it's just going to follow the sodium ions. I don't know the chemistry behind that. It was just explained to me. Just keep in mind that water just follows the sodium ions. Therefore, we call this a mineral corticoid. Okay, and it gets its name because of course, sodium. That is a mineral. Can you think of another mineral that we have talked about in this class? It's not potassium. It has to deal with another mineral balance in the blood. Starts with the letter C. Okay, so it's calcium. That gets regulated by calcitonin, and we will discuss that a little later. Now, I don't know why you would know this other than possibly reading this in the book. Steroid or non-steroid for aldosterone? It's probably not what you would think.
I'm going to go with non-steroid.
With non? Okay. Does everyone agree with that? Said it's not what you would think because typically we attribute steroids to your estrogens, your progesterones, your testosterones. And if that is the case, notice what does it sound like the suffix is for those. Testosterone, not estrogen, but progesterone. Yeah, yeah, and it's a steroid. Oddly enough, aldosterone is a steroid hormone. It's not because of what its function does, okay? And it's not, you could say this has something to do with it, but that means its parent compound must be what? Yeah, it's composed of cholesterol. If you have a type of lipid that has a parent chain of cholesterol, it makes it a steroid hormone. Okay. So we categorize this as a glucocorticoid just because of its function of what it does. As you can see, it affects the glucose metabolism. Now, one of the, hold on, I want to say, it's not, pepsin is not the only enzyme that breaks down proteins. We talked about, what was it, pancreatic lipase, pancreatic amylase, and in this case, the metabolism of glucose is not only done by insulin glucagon. This is another hormone that acts in this function as well. And I really can't explain why. I can just maybe just say this is also true of this. If you are stimulating or releasing too much of this cortisol, then we call that a stress hormone. Okay? I believe the best way to look at that is, in this case, more is not better. Okay? Yes, this hormone does have its regulatory function, but if it's not in balance the way that it should be, okay, for some reason the glucose metabolism slows down. Why that is, I don't know. And sometimes you can see that type, I wouldn't say behavior, but just observe someone. If it doesn't look like they're feeling right, or maybe something is going on in their life that they're just not themselves. Okay, this is one of those aspects that can possibly take place. That's why I call it the stress hormone, because some people, it's nothing that you can really affect and just think about and say, okay, we need to slow this process down. To me, perhaps the best way to combat this, if you can tell someone's feeling down, what's probably the two best thing that you can do for them? One, talk to them. Okay, that's one. What might the next one be? You can just say, oh, they're feeling down. Try to make them do what? Try to make them laugh. I just do that sometimes by talking, because I say such stupid things. So there should be no stress in my wife's life, because you never know the next stupid thing I'm going to say. Like, is this the elementary school? Well, then, yeah, I get called an idiot. So anyway, yeah. So as you can see, this has a function on glucose metabolism. And for some reason, again, more is sometimes not better in this case. I'm hoping that we should only have about 3 slides left. We are on 16 of 18. So I'm willing to bet that the pancreas must be next. Okay, 1, 2, okay, so we just have 2 left. Okay. So one of the aspects we do want you to know, which one of these cells is producing which hormone. Okay. I guess for me, there's a couple ways. You just think of agriculture, or again, okay, glucagon has an A in it, insulin does not. So we've used that example many times, just by knowing chief cells or parietal cells, which ones secrete the acid. We've done that multiple times. And another aspect that you didn't have to do over in the chemistry lab, should some of you have to do that in college chemistry class, if you have to dilute an acid down, okay? For those of you who were performing that lab, when it comes to hydrochloric acid, do you remember the 3, what do I want to say, not comparisons, what's the right word I'm looking for? Concentrations. I knew it started with a C. Concentrated sulfuric acid has a high number. Do you possibly remember what it was? 12. Okay, 12 molar HCl is as concentrated as it can get. You had bottles that were half that concentration, which then, of course, were 6 molar. And then in certain cases, you also had to use 1 molar hydrochloric acid. Should you ever have to dilute that, okay, you never want to have your acid in a beaker and then adding the water. I know it sounds silly. You might say, what's the difference? Well, the physical properties of that acid, when you are diluting that, you always want to add the acid, just on account of Some of you may have noticed that you can smell a lot of chlorine gas and sometimes hydrogen too, because if you're adding the water to the acid, that's just the way that begins to ionize. But if you add the acid to the water, it's much, much safer to do that. So that's another reason when you're diluting them in college, which is maybe one of the things you're going to have to do, keep your A's together. Then you would just say add acid. That means you're adding it to the water. Okay? And again, some of them are much more violent than others, especially when it comes to the sulfuric acid. You're always going to want to add the acid to the water. Okay. And then once you know one of them, that the alpha cells make the glucagon, well then I don't know when it comes to beta with that of the insulin, that's just by default maybe, or once you found one, well then by default you know what the other one is. Okay. Then finally, okay, we had talked about this as a negative feedback loop, and that's exactly what this is. And we will categorize some of these. I don't know if you can see this color over, let's see, I got a glare. It's over behind the screen here. And notice maybe that's not the best way to describe this. It says conversion of glycogen to glucose. It's really not converting it. What's maybe a better way of saying that? Because which one of them is a polysaccharide? Is it glucagon or is it glucose, do you think? Okay. Yes, this is a polysaccharide. Okay, that means it's got many, many, many links of glucose monomers or monosaccharides, however you want to look at it. Okay, so if it drops too far, okay, the hormone glucagon, which is created by what cells? Beta cells or alpha cells? That's right. How did you know that? It has an A in it. I'm pointing to the wrong, pointing to the wrong letter, okay? So with that, once you start breaking those links together, you get more and more and more glucose levels into your blood, therefore it starts to raise. And of course, it's just the opposite. Insulin begins to lower it because you're either going to start to make those long polysaccharide chains, or you're going to cause your body to burn that glucose. It's going to be one or the other. Okay. Anything else? Does everyone have this? Maybe you don't have to write anything for this. Okay. So I'm going to go ahead and shut this down. And then if you could, grab that table that we had started with. It said hormones on top. It said, what was it? Steroid and non-steroid hormones. Okay? We want to categorize these so we can make sense of this chapter, because this is what your final is, not just this table. It's over this chapter. Okay. All right. So we had, I don't think this was on here. Okay? So go ahead and see if you can find that, and then make the appropriate, and leave spaces in between there, because what we're going to do, as you can see, these hormones here, it's kind of like a little bit of a word bank on where they're going to go and why they're going underneath that category.
We don't have this table. We don't.
Okay.
When did we do it?
You might no. You might have been gone for FCCL. I don't know, but we done this in class or haven't we? We have. So I don't. Yeah, it was a while ago, but that's why we're going over it now. Okay. Yeah. And the exact date when we've gone over this, that I can't answer. Okay. Now, some of this seems redundant, you might think, and what I mean by that is notice you have this here, then you see the same thing here, okay? Then you see this here, and then you can say, well, we see it down here, and then down here as well, okay? Well, just by looking at that, why do we want to categorize them the way we're doing? Notice we see mineralocorticoid and mineralocorticoid, okay? But in this case, this mineralocorticoid is steroid based. This mineralocorticoid is polypeptide based, and that's why we break it down in that manner. And then notice here you see glucocorticoid here, here, and here. It's just the chemical structure on why you see them categorized like that. And as you're drawing this out, it's probably not going to be perfect. Heck, even when I was putting this up on the board, it's not going to be perfect that first time through. Now, what I would highly suggest that you do, if you really want to put something into your long-term memory, not that you want to do that, but should you really want to remember this, what's probably the best thing to do for you? You're going to do this again. And what would that be? Yeah, draw it out, write it out. Okay.
The second glucocorticoid?
We mean by this here?
No,
Okay.
like what's the?
A amino acid. Yep. And typically what happens is you could say, well, these are also amino acid based, but what happens, okay, like maybe this is lysine, and then this is glycine, maybe this one's valine. These are all the amino acids, and what happens is as it wraps itself around, we'll put lysine again, and then maybe phenylalanine is another one. These are linked together by sulfur atoms, and that's what makes them polypeptides rather than amino acids. That's something that you don't have to know, but that's why you see them categorized like that. Okay. You might be saying, this is difficult. Well, this is the endocrine system. It's hormones and it's anatomy and physiology. This isn't, I'm just, I'm going to show up to school today and try to make this really difficult. No, that's, maybe. No, not really. I wouldn't want to do that. Okay. So now, the clue, you could say, is sort of like in its name. Okay? So if it is a mineralocorticoid, chances are, what's it going to control? Minerals. If it's a glucocorticoid, it's probably going to control what? Yeah. Sugars and glucose metabolism. Okay, so we'll just start right on down the line. We'll work left to right. So a steroid hormone that also controls minerals is perhaps which one of these hormones that you see here? At least I think it's on. Calcitonin? I mean, yeah, I mean, that is a mineral, but calcitonin is not steroid based. That's why we're going over this. You're using logic. I mean, I would think the same thing. A mineral, well, calcium's a mineral. That's why we're going over this. Okay. How is water conserved? By which mineral? We said water follows this mineral. It follows sodium. Okay. So what hormone did we possibly talk about that does water recycling or water retention? It's a second messenger mechanism. In other words, the backside of your pituitary gland sends out this hormone, ADH, or antidiuretic hormone, and sends that message to the kidneys. Then the kidneys will have this hormone secreted to say, hey, we need to conserve water. But it's a steroid, though. And so if we eliminate the ones that it's not that one, okay? So do we know what controls the male and female gonads of these hormones? Between men and women. Okay, so that would eliminate this one, and then that would eliminate this one, okay? So of these, what might affect glucose metabolism? Okay, so we're eliminating the ones that it's not, okay? And then you would say, okay, so we're getting closer. Do we know the function of thyroxine? What does that do? That does have a hand in carbohydrate, protein, and lipid metabolism, but the problem is it's not a steroid. So that can't go under there. Okay, so now when we get it this far, we've got 3 left. We talked about this one just recently today. We said if someone feels like they're looking down, we said more sometimes is not better. They're secreting too much of this hormone, and cortisol, and that affects what metabolism? It's not minerals. It affects glucose metabolism, so we can eliminate that one. So now you just have it down to aldosterone and epinephrine. Yep, so aldosterone goes here, okay? So we put aldosterone. Okay, and what did we say earlier when it comes to steroids? Yes, they're composed of cholesterol, but a lot of them have this same suffix, which is what? One, O-N-E, which is also 1. Okay, so a mineral corticoid, that's a steroid. What is, and I don't know, I don't want to put like a lot of dashes here, so I just put a dot. You can put a star, a 1, whatever you're more comfortable with. What does this aldosterone do? It conserves what? You can say it conserves sodium ions, or you can say it conserves what instead? Because they both mean the same thing. Conserves water. Okay? That's right. So now a gonadotropin, that's a steroid. Okay? So if it doesn't have a black mark next to it, you can still put that in here. Again, we're eliminating what we know that it isn't to know what it actually is. So what would 2 steroid hormones be that are gonadotropins? Okay, so we've got testosterone, and then we've got estrogen. Now, and would it make more sense for you to use progesterone? Does that make more sense in this case, or do you like estrogen instead? Okay, and the reason we say that there again is notice would have ONE, ONE, and ONE if we put progesterone there. Okay, so what does testosterone do? It affects what in men? It finally causes these to be functional, really, is one way you could look at it. What would it have an effect on? In other words, it affects what? So is it found mainly in men or mainly in women? Yeah, so it's mainly in men, so it affects male reproductive organs. Okay, so we have eliminated this one now. Okay, so what does estrogen do then?
Female.
That's right, it affects female reproductive organs. Okay, and then what is that we talked about today that would have a function on glucose that's also a steroid? So then we start eliminating ones that we know that it isn't, okay? So we actually know which one it is. Cortisol, okay? Cortisol. So then we'll just say you want it slows glucose metabolism or just affects glucose metabolism, because they kind of do go hand in hand. It just depends on how much is actually being secreted. What makes most sense to you? Okay, so it can slow glucose metabolism. Okay. So the steroid hormones that we were responsible for, we're past those now. So let's look at some of the non-steroid hormones that we have been talking about. And there's one more that I wanted to put down here, and that is thyroid stimulating hormone. Okay, so what is it that is possibly in mineralocorticoids? So if it's a mineral, okay, which one of these would you guess would affect minerals in the blood? Calcitonin is one, so we're going to talk about this one. Okay. PTSH, sorry. Parathyroid stimulating hormone. So what counteracts calcitonin? PTSH. Okay, so therefore a mineralocorticoid that's polypeptide based. One is calcitonin. The other is parathyroid stimulating hormone. So what does calcitonin do? Does it raise calcium levels or does it lower calcium levels? And we only did this once. I think we put a box around this because that's significant. So what does that do to the calcium ions then? Why would we put a box around in? Forces it in. Where's calcium mainly stored? In our bodies. In your bones. So this, it's not that it forces, that's just the way we want to associate that it pushes the calcium ions back into the bone. So this will lower calcium ions. So if it's lowering calcium ions, it's lowering the concentration. That would be axiomatic. So if that's what you're saying, that's what's going to happen. So if calcitonin lowers, then parathyroid stimulating hormone must do what? This raises calcium ions. Raises calcium ions. Okay? So that does that one and that one. So we have just a few of these left. So why don't we save them for tomorrow? And then I've got this paper that is due on Friday. You have all week to work on it. Tomorrow we will wrap this up. Okay? Start thinking about how many of you have to or will be taking this final. It's just based over the endocrine system, anything that we've talked about in here. Okay? Anything to add before I close this down? All right, we will catch up to you next time.